Hi students, today we can discuss a topic non-parametric tests in statistics. Non-parametric means this test can be used for non-normal distributions and we can get some inferences based on these values, and this particular test, chi-square test, is one of the non-parametric tests, and it can be used when we have to compare categorical variables, ordinal or nominal data. Here there is an interesting situation. Just think this situation. In one college for one semester, a particular boy, for the 189 days of the semester, sit with one girl for 40 days. They pair each other and walk together for the 40 days, not continuous. In between, okay. But the same boy pair with another girl 2, for 100 days, and with girl 3, 49 days. And this is the crucial situation, that we want to find out whether this boy is specifically associated with any of these 3 girls. It is evident from the data that there is an association here, but we have to statistically prove that this association is significant. And this is the observed frequency of the girl with that boy with that girls. And what is the expected frequency? Expected frequency means among the 189 days, if there is no specific association for the boy with any of the 3 girls, it is expected that the boy can equally share the days with these girls, isn't it? Then 189 divided by 3 is equal to 63. That is 63 plus 63 plus 63 equal to 189. That is, among this semester of 189 days, this boy sit equally with this 63, 63, 63. Okay, right? That is the calculation here. And what is our hypothesis? Our null hypothesis is that there is no difference in the expected frequencies and these observed frequency. There is no significant difference in the observed frequency and this expected frequency. If there is no significant difference in these 2 set of values, we can sure that the boy and the girl have no significant association. Okay. In that way, we can calculate whether there exists a significant association or not. For that purpose, we created a hypothesis like that, H0, there is no difference in observed and expected frequency. Okay, then come to this particular equation. See, in this equation, can you see this? Okay, right. In this equation, it is evident that chi-square, this is a symbol of chi-square. Chi-square is equal to sigma observed frequency minus expected frequency. Yeah, this is the terminology for observed frequency and expected frequency. Observed frequency minus expected frequency square divided by again expected frequency for all the sets, and then sum together. We can sum together, and this is a formula for the calculation. Okay, right. Then we can create this hypothesis, there is no difference in observed and expected frequency. Now do one thing. Okay, we can pass to this equation, first we have to calculate FO minus FE, that is observed frequency of this pair, the 40 minus 63 is equal to this value 40 minus this value 63 equals minus 23, and we can calculate that for girl 2 and girl 3, right? And this calculation is over. Then go for FO minus FE all square, that is equal to this value raised to 2, okay, minus 23 into minus 23 equals 529. In that way we can calculate the square of these three values. Then FO minus FE all square divided by FE as per the equation, okay. FO minus FE all square is here, divided by FE is here 63, yeah, now it is there. Now we can calculate the same for the other two pairs, other two values, okay. Now check for sigma. Sigma means we have to add these values together, that is this value 8.397, then plus 21.73, that is okay, then plus 3.111, okay, this, now it's good, 33.24, that is the chi-square value we obtained, and we paste the value here, chi-square, right? Now we have to find out the table value of chi-square in order to find it, to determine whether this value is significant or not. We have to check the table value. We can open the tables, and this is table, and in this table there are so many numbers. How to read this table? In order to read this table we need DF 000 something like that. To pass through this table we have to find out this DF, and here in this situation what is DF? DF means degrees of freedom. Here degrees of freedom is calculated with the formula R minus 1 into C minus 1. It is not so complex. R means rows, how many rows in the table. In this table how many rows? How many rows of values? These two sets of values. That means the number of rows are 2, right? Then we have to calculate columns. Yeah, 1, 2, 3 columns. That means R minus 1 is equal to 2 minus 1. C minus 1 means 3 minus 3 columns minus 1. Clear? Then 2 minus 1 into 3 minus 1. 2 minus 1 is equal to 1 into 3 minus 1 is equal to 2. 1 into 2 is equal to 2. Yeah. Now the degrees of freedom is 2. That is the calculation. Degrees of freedom is 2. Okay. Now take the table. Again the big table is here, and among this is the degrees of freedom. The 2 is the degrees of freedom for our value. Among the first line, through this line all are our important values. Then which value we have to check? This is for 0.005. This is for 0.01. This is for 0.25. This is for 0.05. What does it mean? Here we need one more criteria, and that criteria is known as alpha. The alpha value for this test, if 95% Actually it is written as 0.05. If the alpha, the criterion value alpha is 0.05, that means we have to check in the table for 0.05. Okay, that is the step we needed here. 0.05. So the corresponding value is 2 to 0.05, that is the value is 5.991, right? The table value is 5.991. Then if the table value is 5.991, then we can go for the decision on H0. The criteria here is compare the chi-square value, the obtained chi-square value 33.24 to the table value 5.991. If the obtained value is greater than the table value, what is the decision? There is a difference. That means we have to reject. We have to reject null hypothesis. This is a condition. If the H0 is rejected, there is no difference in observed and expected frequency is rejected, then what is the decision now? There is no difference in is rejected. There is a difference in expected frequency and observed frequency. That means observed frequency is significant. Observed frequency significant means there is some association between this boy with specific girls, and this association is significant. Okay, this is a funny example of use of chi-square. Here this value means it is significant at 0.05 level, means we have a confidence of 95% that this difference is, this association is significant. Here we can reduce the alpha value to increase the confidence. If we check with this value 9.210, our confidence is again increased to 99%. If we increase to this value 99.511, in that way we can increase the confidence by decreasing the value, but the alpha criterion value is increased. Even this 10.597 is lesser than our chi-square value. So the association is so significant at 99.99999, we don't know. But in order to assure how much confidence we have to obtain exact p value. We can calculate the chi-square using the formula in Excel. Okay, the Excel itself calculate and give value to us, and we can calculate it. For that purpose, just click any cell, click on equal to, and click on fx, insert a function in which we can search for CHI test. Here it is available in statistical category. Among CHI test, go for the list. There are different types of chi-square test is there, in which CHI test is there. Just CHI test, go for the CHI test, or chi-square test. You can for CHIQ test. Just select that test and select actual range. In this box you can see that actual range. Actual range means the actual frequency, the observed frequency. Expected range, that means the expected frequency. Click on this button to select the actual range and go back. Then select the expected range. Here it is calculated. This is expected range. And again go back. And here just click on this particular button, OK. And here we can obtain 6.05 e raised to minus 10. That means 0.000006. The p-value, is chi-square p-value is negative, no, not negative, 0.000008. We can convert it into number, then we can observe the exact value. Among it is, we can convert into number. Yeah, and this is the value 0.000. Actually this is 0.000. That means after 8 zeros there is 6. Okay, no need to consider all those 8 zeros. Just take 0.00. That means our association is significant at 99.999999. How to calculate this exactly means that 1 minus sorry, we have to put equal to 1 minus this value, enter. Yeah, around 100%. We can get a 100% confidence. Actually it is not 100%, 99.99999% confidence that there exists an association between these two variables, classificatory variables. This test can be used for associate to check whether there exists good association between variables. There are two methods: goodness of fit and independence, test of independence. And we can explain the difference between two and analyze the other test in the next video. Thank you for watching.